In today's fast-changing business world, innovation is no longer a random spark of inspiration, but a journey of scientific experimentation. Ries, the Lean Startup 2.0, elevates entrepreneurial methodology to new heights, offering more precise tools and a broader perspective. This in-depth analysis of the classic work focuses on its upgraded content, guiding you through the evolution of Lean Startup principles. Chapter 1: The Evolving Core of Lean Startup. The core of Lean Startup lies in rapid validation and iteration. The Lean Startup 2.0 builds on the three pillars of minimum viable product, rapid iteration, and customer feedback, but refines them into a more systematic methodology. Ries emphasizes that entrepreneurship is no longer exclusive to startups, but serves as a universal framework for any organization pursuing innovation. Compared to the first edition, version 2.0 introduces enhanced tools for data-driven decision-making, emphasizing scientific experimentation to validate hypotheses in complex business environments. For example, Dropbox founder Drew Houston didn't initially build a full product, but tested market demand with a 3-minute demo video. After the video's release, user sign-ups surged, validating the product hypothesis. This approach is further systematized in 2.0, with Ries proposing a closed-loop model of hypothesis-experiment validation, emphasizing data over intuition. He advises entrepreneurs to break down each hypothesis into testable units and validate them quickly through experiments. This closed-loop model applies not only to product development, but also to market strategies, pricing models, and more. The first edition's core can be summarized as: test the market quickly with a minimum viable product, iterate based on customer feedback, and reduce resource waste. Version 2.0 builds on this by integrating advanced data analytics tools like A/B testing and user behavior tracking, enabling entrepreneurs to capture user needs more precisely. Ries also introduces the concept of learning milestones, suggesting entrepreneurs set clear, staged goals to assess experiment progress. For instance, a startup team might set a milestone to validate user demand, using data analysis to decide whether to continue investing resources. To better understand this evolution, imagine Elena, an entrepreneur in London who founded a startup focused on sustainable packaging. Initially planning to launch a biodegradable packaging box, Elena faced limited resources. Using the 2.0 closed-loop model, she first shared a product concept image on social media to gather feedback. She discovered that target customers prioritized cost over environmental benefits. As a result, she pivoted to a lower-cost hybrid material packaging, successfully attracting initial customers. Data-driven decision-making is a core upgrade in version 2.0. To further illustrate the closed-loop model's application, Ries introduces the experiment design template in 2.0. This structured tool helps entrepreneurs systematically plan experiments. The template includes 4 key steps: define the hypothesis, design the experiment, set metrics, and analyze results. For example, Elena used this template to validate demand for sustainable packaging. She defined the hypothesis: target customers are willing to pay a premium for eco-friendly packaging. She then designed a small experiment, posting 2 packaging options on social media, one emphasizing eco-friendliness, the other cost-effectiveness. She set key metrics like click-through rates and comment ratios. The results showed the cost-effective option had 30% higher clicks, prompting her to adjust her product strategy quickly. This template's strength lies in its versatility, applicable not only to startups, but also to innovation within large organizations. For example, global beverage company fictional name, PureFlow aimed to launch a low-sugar drink. Its marketing team used the experiment design template to test different flavors in 3 cities, gathering user feedback and purchase intent data. This rapidly identified the most popular formula, saving months of market research. Ries also emphasizes the importance of experiment prioritization, advising entrepreneurs to test high-risk hypotheses first based on resource constraints and potential impact. For instance, Elena prioritized validating market demand over investing in a production line. This prioritization avoids resource waste, making the lean approach more efficient. Version 2.0 also introduces a systematic tool for analyzing experiment failures, called the Failure Diagnostic Table. This tool helps entrepreneurs extract key lessons from failures to avoid repeating mistakes. For example, Elena's early experiment revealed that overly complex eco-friendly packaging designs deterred users. Using the Failure Diagnostic Table, she identified the root issue as a mismatch between design and user needs, not the eco-friendly concept itself. This led her to simplify the design in the next iteration, successfully attracting customers. Ries stresses that the systematic failure analysis is a major upgrade from the first edition, transforming failure from an emotional setback into a structured learning opportunity. Chapter 2: The Science of Data-Driven Entrepreneurship. One of the biggest upgrades in the Lean Startup 2.0 is the emphasis on data-driven decision-making. Ries notes that in today's business environment, data is the cornerstone of hypothesis validation. He introduces the key metric-driven framework, urging entrepreneurs to focus on measurable core metrics rather than vanity metrics. For example, social media likes may feel encouraging, but user retention or conversion rates matter more. Take Airbnb. Founders Brian Chesky and Joe Gebbia discovered through data analysis that listing photo quality directly impacted booking rates. They quickly iterated, launching a professional photography service that significantly boosted platform conversions. Version 2.0 systematizes this data-driven insight into a metric action optimization cycle. It encourages entrepreneurs to use modern tools like Google Analytics or Mixpanel to track user behavior in real time. Ries also recommends heat maps and user journey maps to help entrepreneurs visualize user behavior patterns intuitively. Compared to the first edition's basic discussion of data, 0 dives deeper into selecting the right metrics. Ries introduces the North Star metric concept, a single metric reflecting a product's core value. For example, Zappos' North Star metric was customer repeat purchase rate, guiding their early focus on service quality over blind expansion. Ries further refines the metric selection process, suggesting entrepreneurs use a hypothesis prioritization matrix to identify high-impact metrics. For instance, an e-commerce platform's matrix might reveal that cart abandonment rate better reflects user experience issues than page views. To illustrate, consider Simon, who founded an online education platform for coding courses in the US. Initially focused on user registrations, he noticed many users didn't complete courses. Following 2OE's advice, Simon shifted his North Star metric to course completion rate. Through A/B testing, he optimized course content, finding short video lessons outperformed lengthy text. This adjustment boosted user retention by 40%. The tools in 2.0 enable entrepreneurs to scientifically identify growth levers. Ries also addresses data privacy and ethics, reminding entrepreneurs to comply with regulations like GDPR and respect user trust. This focus on data ethics reflects 2E's adaptation to modern business realities. To help entrepreneurs apply data-driven decisions effectively, Ries refines the North Star metrics implementation with a metric lifecycle management framework. This requires entrepreneurs to dynamically adjust key metrics at different product stages. For example, Simon's platform used course completion rate as its North Star during the seed stage, but shifted to user referral rate during expansion to measure word-of-mouth impact. This dynamic adjustment ensures metrics align with business goals. Ries also recommends data visualization tools like Tableau or Power BI to present metric trends clearly. For instance, Simon's visualization dashboard revealed low course completion rates correlated with holidays, prompting a holiday-specific incentive program that boosted engagement. Version 2.0 also discusses data bias, warning entrepreneurs to watch for sample or algorithmic biases. For example, a health app might skew toward young users' data, neglecting older users' needs and leading to imbalanced product design. Ries suggests a data diversity check to ensure samples cover diverse user groups. Simon incorporated feedback from varied age groups and professions, avoiding a bias toward tech professionals. To further illustrate data-driven power, consider Mary, who founded an online home decor platform in Singapore. Initially focused on website traffic, she used 2OE's metric selection process to identify custom order conversion rate as her North Star metric. Through or-B testing, she optimized the customization interface, finding a real-time preview feature increased conversions by 25%. Using heat map tools, Mary discovered users lingered too long on the payment page, prompting her to simplify the process, reducing cart abandonment by 15%. These combined tools make data-driven decisions highly actionable. Ries also stresses cross-team data sharing, amending unified platforms like Snowflake to integrate user data. This ensures marketing, tech, and product teams act on the same insights, boosting decision efficiency. Chapter 3: Lean Practices Across Industries. While the first edition focused on startups, the Lean Startup 2.0 expands its scope to large corporations, nonprofits, and even government agencies. Ries believes the core principles of rapid experimentation and iteration apply to any organization pursuing innovation. He notes that large organizations often innovate slowly due to their scale, but lean methods can break this inertia through small-scale experiments. General Electric GE is a hallmark case in 2.0. In its aviation division, GE applied lean methods, using rapid prototyping and customer feedback to shorten engine development cycles and cut costs. Ries introduces the innovation sandbox concept, suggesting large firms create small experimental teams to test ideas in low-risk settings. This sandbox model reduces failure costs and sparks employee creativity. For example, a global retail giant fictional name, or a group faced inventory management challenges. Its innovation team used lean methods to develop a real-time, data-driven inventory forecasting system. They tested a minimum viable solution in one region, optimized it based on feedback, and scaled it globally, saving billions. Ries details how to design innovation sandboxes, recommending team sizes of 5-10, experiment cycles of 4-8 weeks, and resource allocation of no more than 5% of the total budget. Nonprofits also benefit from lean methods. For instance, WaterAid, a charity, used lean principles to test water pump designs for clean water projects in Africa. They piloted in 3 villages, finding simple hand pumps outperformed electric ones in local conditions. This saved costs and improved project sustainability. Version 2.0 showcases lean methods' potential in non-commercial fields through such cases. Compared to the first edition, 2.0 provides detailed guidance for cross-industry implementation. Ries introduces the Lean Transformation Blueprint, helping large organizations transition from traditional to lean processes. This blueprint includes establishing innovation labs, training lean coaches, and fostering cross-departmental collaboration. These tools make lean methods actionable for complex organizations. To aid implementation, Ries introduces the cross-functional experiment framework to break departmental silos and promote collaborative innovation. This suggests forming small teams of product, marketing, and tech staff to design and run experiments. For example, Aurora Group's inventory system team included supply chain, marketing, and data analysts. Through rapid iteration, they tested forecasting algorithms, finding one that reduced inventory backlog by 20%. Ries also proposes an experiment budget allocation model, recommending 3-5 of annual R&D budgets for innovation experiments. Version 2.0 further explores lean governance, emphasizing leadership's role in driving lean practices. For instance, a global logistics firm fictional name Globalink formed a lean innovation committee to oversee experiment progress and align projects with strategy. This committee resolved conflicts, such as when marketing pushed for quick service launches while tech raised quality concerns, by setting clear experiment goals and timelines. Ries also introduces external ecosystem integration, encouraging collaboration with startups, universities, or research institutes to accelerate innovation. For example, WaterAid partnered with a local university to optimize pump durability, cutting maintenance costs by 30%. Version 2.0 provides a lean implementation roadmap with phase guidance, pilot experiments in 1-2 departments, expand training for lean coaches, and fully integrate lean methods into workflows. For instance, an Asian bank fictional name, Asia Bank used this roadmap to adopt lean methods across operations, shortening loan approval times within a year. These tools and cases show that 2.0 supports innovation in complex organizations, not just startups. Chapter 4, Redefining the minimum viable product MVP is the cornerstone of lean startup, but in 2.0, Ries expands its definition. An MVP is no longer just a rough prototype, but a strategic tool for minimal features, maximum validation. He stresses that the MVP's goal isn't to launch a crude product, but to gain maximum learning with minimal investment. Take Tesla. Elon Musk didn't launch a perfect electric car with the Roadster, but a high-priced niche model to validate market acceptance. This strategy allowed Tesla to iterate quickly and launch the mass market Model 3. In 2.0, Ries introduces the layered MVP concept, suggesting entrepreneurs design MVPs tailored to user segments for precise validation. For example, a SaaS product might develop a basic MVP for small businesses and a customized one for large clients. Compared to the first edition, Zero emphasizes strategic MVP design. Ries suggests using a hypothesis map to prioritize product assumptions systematically. For instance, a fitness app's hypothesis map might show users value social features over data tracking, leading the team to prioritize social modules. Ries also introduces the experiment portfolio concept, recommending simultaneous testing of multiple MVP versions to accelerate learning. For example, Spotify tested different music recommendation algorithms in parallel to find the optimal solution quickly. To illustrate, imagine Carlos, a Brazilian entrepreneur developing a health drink. Instead of producing an entire product line, he launched a basic juice in local supermarkets for testing. Feedback showed consumers preferred low-sugar versions, leading Carlos to adjust the formula and expand nationally. This layered MVP strategy is a core contribution of 2.0. To optimize MVP design, Ries introduces user co-creation MVPs, encouraging entrepreneurs to involve target users in the design and testing process. This direct user perspective significantly improves product-market fit. For example, Carlos formed a focus group of local consumers to co-design his juice's flavor and packaging. Feedback showed a preference for portable small packaging, leading him to prioritize small bottles, which exceeded market expectations. Ries also recommends a prototype testing matrix to evaluate MVP versions based on feature completeness, user feedback, and cost effectiveness. Carlos' team found low-sugar juice scored high in feedback and had low production costs, prioritizing its rollout. Version 2.0 also explores virtual MVPs, using digital tools like 3D simulations or AR previews to test concepts. For example, a furniture startup fictional name, Homecraft, used an AR app to let users virtually experience sofa designs, saving 50% on prototyping costs. Ries suggests an MVP iteration cadence of 4–6 weeks per test cycle to maintain rapid learning. For instance, Carlos collected market data every 2 weeks, quickly adjusting bottle designs and labels to launch a market-accepted product in 3 months. Version 2.0 also emphasizes cross-channel MVPs on multiple platforms, for example, online e-commerce, offline retail, to validate channel-specific preferences. Carlos' juice test revealed online users valued brand storytelling, while offline users prioritized price, informing tailored marketing strategies. These integrated tools make MVP design more strategic and flexible. Chapter 5: The Art and Science of Rapid Iteration. Rapid iteration is the soul of lean startup, and 2.0 elevates it to a science. Ries introduces the experiment cadence concept, recommending clear experiment cycles, for example bi-weekly iterations, to keep teams efficient. He emphasizes the value of failure learning, viewing failure as a starting point for optimization, not an endpoint. Take Instagram. Its predecessor, Bourbon, was a complex location sharing app. Founder Kevin Systrom discovered through feedback that photo sharing was most popular, pivoting to create Instagram. In 2.0, Ries systematizes this into a build-test-learn cycle, integrating automation tools like continuous integration systems for faster hypothesis validation. Compared to the first edition, 2.0 incorporates more technical tools. For example, Ries recommends DevOps tools like Jenkins to accelerate development cycles. He also introduces an experiment automation framework, using scripts to collect user data automatically, reducing manual analysis time. For instance, an e-commerce startup might use automation to track click paths, quickly identifying interface bottlenecks. To deepen understanding, consider Nexlify, fictional Japanese startup focused on smart home devices. Founder Misaki developed a smart light bulb with complex features, but iterated after finding users wanted simple voice control. Within 2 weeks, she launched a simplified version, boosting sales. The experiment cadence and automation tools in 2.0 enabled Misaki's team to focus on core value efficiently. Ries also discusses balancing speed and quality in iteration. He suggests a quality gate mechanism, setting minimum quality standards before each iteration to avoid compromising user experience. This balance is a notable improvement over the first edition. To boost iteration efficiency, Ries introduces the experiment automation platform, recommending low-code or no-code tools like Bubble or Airtable for rapid prototyping. For example, Misaki used a no-code platform to build a smart bulb control interface in 48 hours, quickly validating voice control's appeal. Ries also proposes an iteration prioritization matrix to decide which features to iterate first in multi-task settings. Masaki's team found voice control response speed impacted satisfaction more than color options, prioritizing response algorithm improvements. Version 2.0 provides detailed guidance on user feedback loops, recommending systematic feedback mechanisms like online surveys or real-time chat tools, for example, Intercom. Masaki's team discovered user complaints about bulb installation complexity via live chat, simplifying the process from 10 to 5 minutes. Ries also explores AI-assisted iteration, such as using natural language processing to analyze user comments for key needs. Nextlify used AI to analyze forum discussions, identifying energy-saving mode as a top user priority, shaping the next product design. These tools make rapid iteration more efficient and precise. Ries emphasizes iteration culture, suggesting regular iteration retrospectives to share experiment results and lessons. Nextlify held weekly retrospectives, discussing failures like a firmware update issue, improving their testing process. These mechanisms ensure continuous optimization of rapid iteration. Chapter 6: Lean Transformation of Organizational Culture. The Lean Startup 2.0 adds a focus on organizational culture, stressing that lean methods require cultural support to succeed. Ries proposes 3 principles of lean culture: encourage experimentation, tolerate failure, and prioritize data-driven decisions. He argues that rigid cultures in traditional firms hinder innovation, while lean culture sparks team creativity. Take Intuit. The finance software company faced innovation stagnation. CEO Brad Smith introduced lean methods, encouraging small-scale experiments and creating innovation catalyst roles to involve all employees. This led to successful products like TurboTax's mobile app. Ries details how to build a lean culture through training, incentives, and organizational design. For example, a European pharmaceutical company fictional name, Nova, struggled with long R&D cycles. Its leadership adopted lean culture, forming cross-functional teams to test new drug formulas with low budgets. One team validated a new cold medicine through rapid prototyping, cutting 18 months off development. Version 2.0 introduces an innovation scorecard to assess experiment efficiency and cultural fit, with metrics like experiment frequency, failure learning rate, and iteration speed. Compared to the first edition, 2's cultural discussion is more actionable. Ries suggests lean leadership training to foster managers' support for experimentation. He also emphasizes psychological safety, encouraging teams to share failure experiences. Google's Project Aristotle found psychological safety key to high-performing teams, aligning with lean culture principles. Ries also discusses scaling lean culture globally, recommending virtual collaboration tools like Slack or Trello for real-time experiment data sharing across regions. This global perspective makes 2.0 more suited to multinational firms. Chapter 7: The Future Blueprint of Lean Startup. Looking ahead, Ries predicts Lean Startup will become the innovation foundation for all organizations. He foresees lean methods evolving into smart lean with AI and big data, optimizing experiment efficiency through algorithms. For example, Netflix uses algorithms to analyze user behavior, rapidly iterating its content recommendation system to lead the industry. Version 2.0 details how to combine AI tools, like machine learning models, for hypothesis validation. For instance, a retail company might use predictive models to test promotion strategies, quickly finding optimal solutions. Lean startups' potential and social impact is also highlighted. For example, Nonprofit Kiva optimized its microloan process using lean methods, testing new markets and improving efficiency. In Latin America, Kiva's team simplified the application process, increasing loan disbursement rates and cutting approval times from 2 weeks to 3 days. Ries encourages applying lean thinking broadly, from personal career growth to global problem solving. Version 2.0 also addresses the ethical dimension of lean startup. Ries warns that over-optimization may raise privacy concerns or employee stress. He suggests incorporating ethical checkpoints in experiment design to ensure innovation aligns with long-term values. To illustrate this future blueprint, consider Sophia, an Australian entrepreneur developing an AI-based agricultural monitoring system. Using 2OE's Smart Lean approach, Sophia leveraged machine learning to analyze soil data, iterating sensor designs to boost farmers' yields by 20%. Her success showcases the fusion of lean methods with technology. In summary, the Lean Startup 2.0 builds on the first edition with advanced data tools, broader industry applications, and deeper cultural insights. It's not just a startup guide, but a methodology for future-ready innovation. Whether you're a founder or a corporate leader, this book lights the path to innovation.